over root 3, right? Now let's do another one. Tangent, let's say at 3 pi over,
4?
Yeah, let's do 3 pi over 4. Okay, what's the x-coordinate point at 3 pi, the y-coordinate point at 3 pi over 4? Root 2 over 2. And then I'm going to multiply by the reciprocal of the x-coordinate point. And what is the reciprocal of the x-coordinate point?
Negative 2 over the square root of 2.
Very good. So then what's our answer going to be?
Negative 1.
Negative 1, because the 2's cancel out, but so do the square roots. So we're going to be left with that negative 1. Anything that's over 6 for tangent, what did you guys notice? How does the answer look like anytime it's over 6 for tangent? Good, it's going to look like something like 1 over the square root of 3, whether it's going to be positive or negative, right? Sometimes it's going to look like the square root of 3 over 3. Because if you guys remember up until now, we can't have roots in the denominator, so we would have to rationalize the denominator. So it would equal to the square root of 3 over 3. Okay, it can be shown in both ways. You just have to know that they are the same value, right? What about anything that's tangent where it's over 3? How does that answer look like? It looks like a root 3, right? Whether it's positive or negative. Okay, so tangent, let's see, tangent. I think I put them all the way down. Okay, so this one has an over 3, so the answer is going to look something like the square root of 3. You just have to decide if it's positive or negative. How can you determine where tangent is positive or where tangent is negative?
Quarters.
Okay, how?
By the corner.
How?
If it's negative, then negative, so this is going to be positive.
Good, so if one x value or one y value is negative, then tangent is negative, right? What's one acronym that I showed you guys to help you identify where tangent is positive? All students take calculus. So all quadrant 1 and take for tangent is in quadrant 3. So tangent is positive in quadrant 1 and quadrant 3. That's where both x and y have the same sign. Questions? So far, so good? All right, any questions of anything so far? I'm not gonna lie to you guys, it starts to get a little tricky, okay, but with enough practice, it will make sense, okay? I don't wanna lie, it does get a little tricky, but it will, with enough practice, it will make sense. All right, so let's go ahead and continue with today's material, okay? Tell me at least 3 things that you know or remember about inverse functions. Okay, tell me at least 3 things you know about inverse functions. At least 3. But you can give me more than 3. Oh.
You were doing for the 6. Look, X and Y.
Let's take a look at some of these. I know some of you guys are still typing, so let's go over some of these right here. All right, change x to y in original equations to solve for the inverse.
All right, so if you're already given the inverse, you switch the x and y to find the original function. Very good. Okay, the x and the y values do switch. Very good. Okay, woo, the x and the y switches. I'm sorry. The x and y switch, right? That's what it says. X and y values swap. Very good. Okay, so this is a notation. It looks like a -1 at the exponent, right? But that's just the inverse notation. Okay, so the values of the table are swapped for the inverse function where compared to the parent function, and then we solve for x. Very good. Opposites. What do you mean by opposites? Like they switch? Gotcha. Okay. Opposite. Okay, so the opposite of the original function, the inverse, what is HA? The inverse.
Horizontal asymptote.
So the inverse horizontal asymptote is a vertical asymptote. That's a good one. I haven't heard that one. Very true. Okay, so if the function has horizontal asymptotes, then the inverse has vertical asymptotes and vice versa. Very good. Ooh, this is also a good one. It does reflect over the line y equals x. Okay, there's a misconception that a lot of people put down that it reflects over the axis. It does not reflect over the axis. In order for the x and the y to switch, it has to reflect over the line y equals to x, as the key mentioned. Very good. Okay. The inverse of an exponential is a log. Very good. Okay, they operate by using opposite signs and symbols. They reflect it over the y-axis. So it's going to be the line y equals to x. Okay. The original points, x and y values are swapped. Very good. So the x becomes a y, the y becomes the x. Inverse functions are a reflection over the y equals to x. Okay. Y gets to change to y. Okay, replacing f of x with y. All right. That's the notation. Very good. Let me see. For the most part, you guys mentioned a lot of good ones. Very good. Reflecting over the line y equals to x. Very good. Okay. So let's go ahead and now go to 3.9, which is on page 6, I believe. All right, so for today, okay, today and tomorrow, which by the way, we won't get to finish today. So for today and tomorrow, we're going to go over inverse trigonometric functions and understand that their inputs and outputs are switched. Okay, the input ratio for an inverse, okay, it's going to be your coordinate point, and the output is going to be your angles. Okay, the input outputs are switched, as you guys mentioned. Okay, explain why and how the domain for sine and cosine and tangent must be restricted. Okay, and then after all that fun, we're going to evaluate some trig expressions. All right. So, like I said, page 6, there's 2 different ways to notate inverse trig functions. Okay, and I'm going to use sine for now. Okay, we can use that -1 as the exponent. Remember, it's not an exponent, it's just a notation. Inverse sine or arc sine. Regardless, both of them can be read as arc sine. The same thing for cosine is the same thing as arc cosine, or the inverse of tangent. Okay, they mean the exact same thing. So regardless of what you put down in your calculator, it's going to read as the exact same thing.
You have to spell that out. Why did you do this?
For arc sine and arc cosine and arc tan, yes.
Did you do that for sine also?
Yes, you're going to do it for sine also. All right, so the input for the inverse is the coordinate point. And the output would be what? The angle, right? Again, this is for the inverse. Because for sine, cosine, and tangent, the input was the angle and the output was the coordinate. So it would make sense as to why the inverse is swapped, right? So let's take a look at this one right here. They give us that sine at pi over 6 equals to 1/2. That's true, right? Sine at pi over 6 is 1/2. where the input is pi over 6, right? And then this is the output. Well, now they want us to write it as the equivalent form using the arc sine notation. So arc sine. What is going to be the input of arc sine if I want to use the equivalent form? 1/2. Very good. And what's going to be the output? Good. Now this is the equivalent form using arc sine. Literally, the inputs and outputs are swapped. As many of you guys mentioned, right? Yeah. Say that again.
No, I just.
I was going to do this question next, but actually let me save that one until we get closer to where we need it.
Yep.
So let's talk about arc sine and regular sine. You guys agree that this is a graph for sine, right? And it continues on and on and on and on, right? The domain for sine, what is the domain for sine? The domain. Yes. All real numbers. Very good. All real numbers. So from negative infinity to positive infinity, right? And what is a range? What's a range for sine? -1 to 1, right? Including -1 and 1 or not including? So is that brackets or parentheses? Brackets. Very good. Now, one thing I didn't see on things that you know about inverse functions is that all equations have an inverse. But there's a difference between having an inverse equation and an inverse function. Someone remind me, what is a function? What makes a function a function?
It allows us to plug in the value for the equation.
Okay, so what does it differ between? Let's do a couple examples before I go over this. Is this a function? It is a function. What about this one? Is this a function? Yes, this is a function. What about this one?
No.
Why not? Doesn't pass the vertical line test. A function must pass the vertical line test, meaning x values cannot repeat and have repeating y values. Okay, so if you look at this x value right here, it has 2 y values, right? That makes it not a function. Okay, one x value cannot have multiple y values, so therefore it's no longer a function. So these two right here that are a function, okay, one of them will not have an inverse function. All of these do have an inverse, but the inverse for one of these, right, these two right here will not be a function. Which one would it be? Would it be the parabola or the cubic? The cubic, you say it will be a function, an inverse function, or not an inverse function?
No.
It will not be an inverse function. This will actually have an inverse function.
The parabola?
Why the parabola?
Because it's gonna rotate 90 degrees.
This does have an inverse. It just won't be a function. Okay? But the inverse because what? Not quite. What test will it not pass? Good, but how can you tell just by looking at the parabola? What's a one test that we can do to see if the inverse will be a function? The horizontal line test. It doesn't pass the horizontal line test. So, in order for a function to have an inverse function, just like a cubic, what must be true about the function within itself? It has to pass a horizontal line test. Okay, does this cubic pass a horizontal line test? Yeah, so it will have an inverse, and the inverse will be a function. Do you guys see the difference? All equations and all functions will have an inverse. It's just determining whether the inverse will be a function or not. So now let me ask you guys this. Does sine have an inverse function? Why not? It doesn't pass a horizontal line test. Do you guys see how this inverse right here doesn't pass a horizontal line test? So in order for sine to have an inverse function, we have to restrict the domain. We're restricting the domain from negative pi over 2 to pi over 2, just like right here. If we restrict the domain, does this part of the sine pass the horizontal line test? Yes. Now that it passes a horizontal line test, now the inverse graph will pass its own vertical line test. Okay, so in order to have an inverse function, we have to restrict the domain for a sine from negative pi over 2 to pi over 2. Okay, and this is the graph. This is how the graph is going to look like for our sine. All right. Now that we have a restricted domain in order to create our inverse for sine, what is the domain and what is the range for the inverse of sine? You don't know? Neither do I. Man, this sucks. Y'all need a better math teacher, huh?
Oh.
Ooh, what did you say? I heard it. You said one, well, you said 3 words that I was looking for earlier. Those are not 3 words. It's a 1 word that has 3 letters. Well, at least somebody said it right here. Maybe it was Caleb.
Oh, that now you
Yeah.
based on the history
So nobody said it? It is 1 to 1. A function must be 1 to 1 in order to have an inverse. You said it, Juno. I knew you said it.
20. 25. That's like
But that's basically what we call the horizontal line test. The proper way of saying the horizontal line test is that a function must be 1 to 1. For every x value, it has 1 y value. For every y value, it has 1 x. All right, let's have a look here. All right, so the range for the inverse of sine or arc sine is from negative pi over 2 to pi over 2. Okay, the domain is from negative 1 to 1, and this is where people start getting a little confused. The domain for sine is still negative infinity to positive infinity. Okay, I didn't ask about the restricted. How much do we have to restrict the domain for the inverse? The domain for sine is still negative infinity to positive infinity, and the range is still negative 1 to 1. Questions?
It's pretty much a trick.
I didn't trick you, right? I didn't ask what is a restricted domain in order to have an inverse, right? Make sure you're reading the question carefully. Remember, I did say it's going to start getting a little tricky, but with practice, it will get easier, right? Oh, I'm not trying to trick you. All right, now let's talk about cosine. Cosine, does it pass the horizontal line test? But it is a function, right? It passes the vertical line test, but it doesn't pass the horizontal line test. What is the domain for this cosine here? All real numbers, negative infinity to positive infinity. And what's the range? Very good. Negative 1 to 1. Since it doesn't pass a horizontal line test, in order for the inverse to be a function, we have to restrict the domain from 0 to pi. Does this restricted domain now pass the horizontal line test? Yeah, so since it passes a horizontal line test, I think he mentioned, and I forgot who else mentioned it, we're going to reflect it over the line y equals x, and this is how we get our inverse of cosine, okay? Or we just switch the x and y coordinate points. All right, so once again, we restrict the domain in order to get an inverse function. So now you tell me, what is the domain and the range for the inverse of sine, for the inverse of cosine and just cosine? Yes, I have to change it after this. Just remember. Sounds like one of those stop signs. Wait.
I'm gonna try. Glad we getting through it.
All right, let's have a look and see what you guys put down. Not yet? All right, let's see. Okay, which one did I ask first? The range. The range for arc cosine is from 0 to pi. Very good. The domain for arc cosine is -1 to 1, which makes sense why the domains and range switch, right? Because the x and the y's also switch for the inverse and the function. Okay, the domain of cosine is still -infinity to positive infinity. The range for cosine is -1 to 1. All right. Same deal with tangent. Okay, same deal with tangent. Is this tangent, does this one here pass a horizontal line test? No, doesn't pass a horizontal line test. What is the range? Let's do the range first for tangent. What's the range for tangent? All real numbers. Very good. It's all real numbers from -infinity to positive infinity. So it's all real numbers. What about the domain? Not all real numbers. The asymptotes. It's all real numbers except the vertical asymptotes. And where are the locations? Very good. What's K? Good, good. Okay, I'm not going to put it down, but we know that K represents an integer, right? All right, so in order to have an inverse function, we have to restrict the domain, and we're restricting it from -pi/2 to pi/2. But notice how this one doesn't have the brackets, just like inverse of sine and, well, yeah, just a sine. Okay, why?
It's not equal to.
Good, it's undefined. There's vertical asymptotes there, right? So now, what is the domain? I can't even spell. Domain for arctan. It's all real numbers. Very good. Okay, what about the range?
No, it's not, because it's working like that, yeah.
Oh, it's
pi/2. No, -pi/2,
Oh, yeah, 'cause we isolated it.
Yeah, wrong.
Okay, brackets or parentheses?
Parentheses.
Parentheses. Very good, not equal to, very good. I know.
I think
Question. Yes, this is for the inverse of tangent. Right, so if this is the inverse graph for tangent, the domain is all real numbers, right? And it's restricted from negative pi over 2 all the way to pi over 2. In order to, yes, so we restricted the domain to make it 1 to 1. So originally it didn't pass the horizontal line test, right? But now that we restricted, well, now it's passing the horizontal line test. In that case, now we can reflect it over the line y equals 2x, where we switch the x and the y values, and this is what the graph of the inverse of tangent becomes. Does that make sense? All right, any questions? All right, so last piece before we finish for today. Okay, look at this picture here. Okay, this is where your answers for your inverse of sine, cosine, and tangent will be located. Okay, since your range for inverse of sine is from negative pi over 2 to pi over 2, your answers can only be located in quadrant 1 and in quadrant 4, meaning that 5 pi over 3, 7 pi over 4, 11 pi over 6, and 3 pi over 2 should not be an answer for your inverse of sine. Okay, so instead of saying your answer is 11 pi over 6, your answer is going to be negative pi over 6, because 11 pi over 6 is not within this range. Okay, it has to match its range. The same thing for the inverse of cosine. Your answers can only be in quadrant 1 and in quadrant 2. Inverse of cosine is a little bit easier because all of these right here, those angles are between 0 and pi. But the same thing becomes with tangent. Your answers have to be in quadrant 1 or in quadrant 4, and it has to match the range. Yes.
And also with that one, with tangent, it does not include
It does not include negative pi over 2 or pi over 2. And I know this might not make sense right now, but we'll do examples tomorrow. Yes.
ever be the discussion where it helps
Yes. We'll see that Friday. Okay, that's a good question. Brielle is asking, is there an answer where we're going to come across where it has to be in a different non-shaded quadrant? And the answer is yes. There is a difference of some sort of question. So we'll get to that. Okay? Yes.
Can you pass me mine? 24.
Eight. It cannot be an answer.
Well, look at the other. Yeah.
Oh, okay.